purpose of math class? Like, why do we even teach math? Would you consider that many of us grew up in a circumstance where the purpose of teaching math was all about getting answers? Everything was about helping kids get answers to math problems. Now, if you're like me, the first time I heard Phil Darrow say this, I said to myself, yes, that is the purpose of math class, is to help kids learn how to get answers to math questions. So let me go a little further on that. What that means then is, whatever I'm going to teach today, pick it, addition, multiplication, division of fractions, solving quadratic equations, whatever it is that you're going to teach today, I say to kids, I say to myself, okay, let's see, what is the most foolproof, kids in lockstep can all copy by the end of the hour, they're all getting it right, nobody's fussy, nobody's struggling, they'll circle their answer, they take it home, parents recognize it, that. Whatever that is, bam, kids are getting answers to questions without struggling. That's how I'm getting it. They're all getting the right answer. Everybody's like, parents recognize it. That's how I'm going to teach math. If the purpose of teaching math is for kids to get answers, that makes all sorts of sense. And of course you would want to do that. What if that's not the purpose of teaching math? I just dropped my pen. Now I have to bend it in front of the whole audience. With a boot on my foot. I can do it. Okay. Now I'm pulling the thing out of my hair. That was graceful, I'm sure. So, if the purpose of math could actually be to develop mathematical reasoning. Now, caution, you might read that and you might say, Pam, you can't teach kids to just think better. That's like fuzzy think better. No, actually, I agree. There's a bit of research out there. You can't just teach kids to be better thinkers. They have to have content involved. So notice that I said I want to develop mathematical reasoning. That means I want kids reasoning mathematically. That means they own content better than if you're just rote memorizing and mimicking squiggles and waves. You're actually reasoning mathematically. Now, I created this graphic to send several messages, one of which we are going to talk about today. I know it's a little bit busy, so bear with me for just a second. Let me sort of parse out some of this. I'm suggesting that there are areas of mathematics that are hierarchical. That means they are built on and based on each other. That means that if I'm at this largest oval on the outside is the high school function reasoning. If I want kids to reason about functions and relations and graphs and tables and transformations at the high school level, that's built on and based on proportional reasoning, which is the land of the middle school. And that's built on and based on multiplicative reasoning, which is the land of the 3rd, 4th, 5th, 6th, 7th grade teachers. And that's built on and based on additive thinking, which is the land of the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th grade teachers. Notice a lot of overlap there. Middle school teachers have a lot to do. And that's built on and based on counting strategies. Now, right now, you might be bored. You might be like, Pam, these are just our standards. First kids count, then they add and subtract, then they multiply and divide, then they solve proportions, then they do that stuff no one understands. Thanks for the chuckle. But I actually don't mean that it's just kids getting answers to addition and subtraction questions, and kids getting answers to multiplication and division questions, and kids solving proportions. I actually mean that we are literally helping kids build new strategies, that we're literally helping them reason more complexly, that we are helping them reason more sophisticatedly, handling more things simultaneously, and that takes effort. It's like you go to the gym and you have to lift weights to get stronger. We have to have kids grapple with mathematical ideas for their brains to be able to then deal with those mathematical ideas. So what does it look like then to be a trap of an algorithm? How can we avoid the traps of algorithms? Could you guys agree with me back here, come back, that we did a lot of math here, but one of the things we did was find 49 bags of M&Ms that had 27 M&Ms in a bag, yes? Would you guys all agree with me that kind of naked, that problem is like 49 bags times 27 M&Ms per bag? Did we solve that multiplication problem? If that's a multiplication problem, where does it belong in this sequence? Well, it should be in multiplicative reasoning. Everyone's like, duh, this isn't hard, yes? If we're solving a multiplication problem, then kids should be developing and using multiplicative reasoning. Well, dive with me quickly actually, before we do, how did you solve it? When you found 49 bags of M&Ms with 27 M&Ms per bag, you said, 49 27s. I know what 50 27s is. So if I have 50 27s, I can just get rid of a 27 and bam, we got 40. You were thinking about 49 27s. Everybody agree with me? Now dive with me into the algorithm. Notice, as soon as we do, that the algorithm says, hey, start over here and think about 9 times 7, 7 times 9. The least consequential numbers of the problem. When you found 49 27s, did you think about 9 times 7, 7 times 9 at all?
No.
Not even once. Could you imagine being the kid who's like, okay, I need to find 49 27s. And the teacher goes, the way you do it is do 9 times 7. That's weird. I'm thinking about 49 27s. You want me to think, oh, I guess I'm not a math person. When in reality, your intuition was brilliant to be thinking about 49 27s. So instantly, we work against kids' intuition and we turn the problem into a bunch of digits. Now run with me. So if we're doing that 7 times 9, 9 times 7, the kid could say, I need 9 7s, 7 9s. Ready, begin. 9 plus 9 is 18, plus another 9 is 27. Could I literally add up a bunch of 9s or maybe up a bunch of 7s? Could I get this answer correct and then, whoops, get that answer correct and put that up here and then do this one and get that one and then the magic 0 where the turtle lays an egg and then all of the things. And could I do all of that and get the answer correct? And the teacher says, yay, you're a multiplicative reasoner. When in reality, we solved every one of those single-digit facts with what kind of reasoning? Additive reasoning, because we added up those 9s or those 7s. What if instead I had kids just, you're like, Pam, my kids don't skip count. I make them memorize those facts. Oh, you mean they're not using reasoning at all? Now you're not even on the chart. Somehow that doesn't feel better to me. Now you're just doing a bunch of single-digit memory things, and we're saying, yay, you're a multiplicative reasoner. When in reality, you were a memorizer? Now, that's not me saying you're bad. That's me saying we've had a global communication problem about the nature of math. We thought the goal was to get answers, so we were given and then we've given kids ways to get answers that don't actually build reasoning because we could get stuck in reasoning in the level before. For those of you that teach younger grades, do you remember when we did that? We found 1350. Do you remember we had 1,350 that's a 5, in 50 bags? And we had to subtract the 27 M&Ms. Well, if I do that in an algorithm over here, what if I even do that correct? So there's that, and I cross that out, and then I think about this right here. That's super messy, but it's 10 minus 7, yeah? Could a kid, in that, if they're solving a subtraction problem, what kind of reasoning should they be developing and using? It should be additive reasoning. Could a kid then do all the steps correct, get to that 10 minus 7 and go, 10, 9, 8, 7, 6, 5. Could they literally do that subtraction counting by ones and get this answer correct and then keep going and do all of these single digit subtractions counting by ones and we say, yay, you're an additive reasoner. When in reality, they were using counting strategies the whole time. Middle school teachers, not letting you off the hook. What if I gave you a proportion, A to B, C to D? How do we tell kids to find answers to proportions? Cross, multiply, and divide? Y'all just say those words out loud with me. We're supposed to be developing and using proportional reasoning, but we're going to cross, multiply, and divide. So if I get kids solving proportions using cross, multiply, and divide, at best they're using multiplicative reasoning. And what if they're doing the multiplication and division using the algorithms? They could be using additive reasoning. And we get what we've gotten. We've got kids getting answers to math questions, rote memorizing and mimicking squiggles and waves, but never building the reasoning that the problems were intended to develop. Y'all, we can avoid the traps of algorithms. First trap, the less sophisticated reasoning trap, that we should be developing and using a certain kind of reasoning. The algorithms allow kids to use less sophisticated reasoning. It's probably the most important major trap. But another trap is the digit-oriented trap, where high school teachers think in a polynomial, it's like we separate it by terms and we only ever look at the term of highest degree. Like we turn everything into its like component parts and we only deal with those. We don't ever think about the thing as a whole. What does it mean to add a parabola plus a line? Maybe hang around for my breakout session if you want to hear more about that. Which actually, don't let me forget to tell you what my breakout session is all about, so you know if it's a good one for you to come to. So digit-oriented trap is we break everything up into these little teeny squiggles and waves, and we do stuff with them that isn't mathing at all. And then we have the definition of math trap. If you believe that math is you either see the shark or sucks, you don't. Or the shark is about squiggling and waving, and the definition of math isn't mathing at all, then your identity takes a hit. If you're the kid who's like, I can't do all that memorizing, I guess I'm not a math person. Or what if you're even me, who said, I can memorize the best of them, bam. Then I figured out I wasn't mathing at all. Like I thought I was a math person and then realized I didn't rote memorizing and mimicking. I don't know if you can imagine as a high school math teacher the hit that took on my psyche. That was a bit of a midlife crisis right there, where I was already having enough imposter syndrome, I was one woman with a department of 8 men. So there was enough of me trying to like prove that I belonged in that department, and then I began to have this inkling as my kid was growing up that I wasn't mathing at all. So I want to give to you the gift of saying it's okay. It's okay wherever you are and wherever you have thought about math. The good news is it's only up from here. We can all math better and better as we go, and it's a beautiful, wonderful, creative world. Mathing is so much more interesting and intriguing than it ever was to rote memorize and mimic. So how do we avoid the traps? I'm going to mention 2 ideas quickly that I'm going to dive into in my breakout session. So first is an instructional routine called problem strings. It's my favorite way of teaching. It's not the only way of teaching, but it's a super good inroad, and experts can use as well. So we did a problem string today. I'm realizing I'm missing a slide, which I'm not sure why. So pretend there's another slide here. It says, and we can build the foundations for strategies. So I'm advocating that there's a small set of relationships that lead to a small set of major strategies. I'm going to talk about problem strings to teach strategies, and then a foundations for